In this lecture, we will discuss about the theory of depletion layer or a p-n junction. You know very well, take a p-type material and n-type material. Just join together, both the materials are meeting at the particular point. This area is known as p-n junction because p-type and n-type material are meeting together and it forms the p-n junction. Junction means meeting. So you know very well, in n-type material there is an excess of electrons. In p-type region there is an excess of holes. Holes mean it is ready to accept the electron. So it is positively charged, it is negatively charged. So what will happen if I bring or if I connect plus and minus? So automatically some of the electrons it will try to go to hole side or p-type side. So plus and minus combined together it forms an immovable ions or immobile ions. So this yellow color shows that, so here this negative ion, this electron is combined with the holes and it forms the immovable or immobile ions. So this is it is an insulating layer. It is just like a compound wall. So this negative electrons and positive both will combine together. If you add plus 1 and minus 1, what will happen? You will get 0. So this is minus 1, this is plus 1. If you add it both, you will get 0. So 0 means it is an insulation layer. So this layer is known as depletion layer. So it is, consider this is an holes or the opposite side is electron, in between there is a compound wall. So this person cannot go into that particular region, and the second person, the team B person, cannot come into the team A region. So this depletion region or this insulation layer, it will protect or it will restrict the movement of electron from n type to p type, as well as it restrict the movement of holes from p type to n type. It acts as a barrier. So this layer is known as depletion layer. So you know very well, a layer is formed on both the sides of the junction. This layer is depleted of free electrons and holes. The region around the junction from which the charge carriers are depleted is called depletion layer. So because of this layer, this electron, it cannot enter into the p side, and due to this, these holes it cannot transfer to the n side. So this depletion layer, it restricts or it opposes the movement of holes and electrons. So finally it is an insulation layer. It means there is no charge. So what is potential barrier here? You know very well, the holes are positively charged, the electrons are negatively charged, almost it is positive and negative. In between I have an insulating layer or dielectric. Dielectric means it is an insulator. So what will happen if I place a dielectric in between the positive plate and negative plate? Automatically the dipoles are induced, because these positive atoms, these positive holes, it will induce negative charge on the dielectric, and these negative charges, it will induce positive charges on the dielectric. So the negative charges are induced because of the induction, and the positive charges are induced here because of the induction of negative charges. So there is a plus and minus, in between there is an electric field. If you have positive charge and negative charge, automatically that electric field will be developed across this. So this potential is known as cut-in voltage or barrier potential. The potential difference built across the p-n junction, which restricts the further movement of charge carriers across the junction, is known as potential barrier. So generally for silicon, this potential barrier will be 0.7 volt, and for germanium it will be 0.3 volt. So this is the complete view of p-n junction diode. So diode means, di means two, so it has two terminals, anode and cathode. So this is a symbolic representation of diode. So this is an ohmic contact or metal contact, and these are the famous type of diode IN 1N4007. The remaining thing we will discuss in the next lecture. Thank you.